Alright, good morning everyone. Hope y'all are having a good day. So we're going to talk about Chapter 20 today, Software Development Security. I'll be honest, most of this chapter should be reviewed from Systems Analysis and Design. So we'll probably go through it and then probably have about half a class to work on your projects or whatever. Alright, so first we're going to talk about System Development Controls. After that, we're going to jump in and talk about establishing databases and data warehouse. I'll talk about storage. We're going to wrap up talking about knowledge-based systems. So, the entire goal of software development, as the name software development will imply, is to create applications. Okay, and these applications can range from a traditional desktop application. I'm looking around the room, I see a few people using web browsers. Okay, you can use whatever you want, by the way, I'm not calling anyone out. That's an application. Alright, and, web browser can access, obviously, stuff online. Okay, and typically it's going to be using HTTP, HTTPS protocols. You can use many others as well, but those are the common ones that a web browser would be using, of course. And with those technologies, okay, we can develop online applications. So imagine if you were going to Canvas. Right, Canvas is an online application. If you're going to your webmail, that's an online application. All right, there's a lot of different things we can develop. All right, think about mobile applications. Why might we want to develop a mobile application? People use mobile applications. Okay, if we're a profit-seeking company, why might we want to use a mobile application? Exactly right. All right. So maybe we're using it internally. If we're using a mobile application internally, could be that we found that it reduces costs. Maybe transaction costs, maybe the amount of time it takes to complete a sale. Whatever the case is, we're presuming that it's going to save us money. Say we're wanting to sell a license to the online app. How does that make us money? Not a trick question. Okay, and that leads to what? Revenue, which leads to what? It should lead to profit. I'm not going to say it always does. You're exactly right, Ron. All right. Ron, you're looking forward to about, 2 or 3 weeks from now? I think you're ready to graduate. Understand revenue and profit. All right. That's actually a lot more to a business degree than that, of course. But that's the important stuff, is it not? Okay. So the reason I'm bringing all this up is to sort of set the stage. There's a lot of different ways we can develop applications. All right. So last semester, you all had Paul for systems analysis and design, right? What's agile development? Okay. What about system development lifecycle? It's a 4-step process. It repeats itself, basically. What is it? So, you're going to be doing some planning. Okay, you're going to be doing some implementation. You're going to be doing some testing. You're going to be doing some reflection. All right? Those are the 4 major steps. And the idea is that it's a cycle, which means you go back to step 1. All right? Now, you don't have to go back to step 1 after you're on step 4. You could go back to implementation. You could go back to step 3. There's a lot of flexibility with it. It's not as rigid as some people may think. Now, something that is rigid is the waterfall method. What's the waterfall method? Exactly right. All right, and you don't go back. Okay, if you have a waterfall, it goes downhill. Does it ever go uphill? Okay, I've certainly never seen a waterfall go uphill. All right, so that's the idea here. It's that the waterfall, once you've completed a step, you don't go back. But, as we know, these are generic frameworks. Whatever company you're at probably has their own way of doing stuff. Is that bad? No. Is it good? in and of itself, it's neither good nor bad. It's all about how effective the end result is. All right? Imagine your company makes good software. Does it matter how? If you're an investor, are you going to say, I only invest in agile companies? You might, but that doesn't mean that agile is going to be profitable all the time. Certainly doesn't. So different companies have different culture. Think about a company like IBM versus a company, just pick any startup. IBM's been around for over 100 years. You think the way they do stuff is different than how a startup does stuff? How so? They're extremely structured. Very hierarchical organization, IBM. I'm not going to say the most because how do you measure that? But they're certainly extremely hierarchical. I don't think anyone in here would disagree with that. All right, I'm always up for a debate, but I think that I'm right. All right. So firm specific is more likely what we're actually going to see in the real world. All right. You may have a company that says we're agile. We do everything with agility. All right. We're not hierarchical. But you get there, is that truly the case? Probably not, right? It's probably going to be some hierarchy. Maybe not formalized hierarchy, but there's certainly going to be an informal structure of things. Let's talk about some different project management tools. You got your Gantt chart. Basically, the idea of a Gantt chart is you break down all your tasks. You can break them down into sections, and basically you're scheduling them out. Okay, so in this case, this is organized by looks like a week. Okay, so they're saying week 1 we're doing the first task. All right, and the idea is that this sort of helps everyone understand who's working on whatever development task or generic project, doesn't have to be for software development. Helps them understand what tasks should be completed when. Now, what are some downsides to Gantt charts? Okay, let's say you complete the first task in 1 day and it was allocated 5 days. What are some downsides for that? Okay, it has a hard time showing, slack or anything really. What else? Say you finish early. Why not just sit on your thumbs the rest of the week, especially if you're working from home? Why not? Just face it. I'd rather be playing with a puppy. Sure, you all would rather be playing with a puppy, or whatever activity you like to do. I don't know. Sure, a lot of you probably like to do some gaming. If you get finished early, why not pop open a game? What are some other downsides with Gantt charts? It's a big one. Yeah, not being able to sort of move backwards. I mean, you can't go back in time. It's organized by time. One more that I'm thinking of, though. This shows how many possible timelines. 1. Some stuff's going to be finished early. Some stuff's going to be finished late. This does not account for that at all. So to make any change, let's say we get to week 5 and we fall behind a week. We have to change everything, right? That's pain. All right, so to address that, you got your buddy the PERT chart, okay? So basically, it stands for Program Evaluation Review Technique. All right, what you're doing is you're having your activities all laid out. You're having the paths required to complete them. It's another thing we don't really do I mean, it is technically inside of a Gantt chart. It's a lot more visual inside of a PERT chart, though. Is that fair to say? The order in which stuff may be completed or must be completed. So basically, you have your critical path. Okay, that's going to be the one that's going to have any amount of delay will delay the overall project. All right, and that's typically going to be the one that's going to be straight across. It's called the critical path. All right, and the idea is that you have early start, you have an early finish, a late start, and a late finish. All right, and that's basically accounting for the best case scenario and the worst case scenario. So it just provides a little bit more information than a Gantt chart. All right, any questions about charts? It's a review from last semester, right? I think it should be. I don't know exactly what's covered in systems analysis here, but pretty sure you all covered charts. Either that or in project management. You all take project management too, right, with Eric? Probably covered it in one of those two classes, I'm pretty confident in. So change management. Talked about it before, and we said that it's going to be the formalized process and procedures for implementing change. What is change? It's not a trick question. What is change? Exactly right. Okay. So we're talking about, in the context of this class, we're talking about making changes to an organization's technology systems in some way, shape, or form. A lot of times this could be an update. Sometimes it may be a new version of something. For instance, a couple of years, what's going to happen with Windows 10 support? It will be. All right, will they extend it? I don't know. You know, they've extended it before. I was surprised that they didn't extend XP support at least a year or two. Or not XP, Windows 7. Sorry, guys, been staying up a little bit. Or not staying up, getting up a lot. Anyway, you get the idea, okay? Now, they did extend Windows XP a couple times, actually. But they did not extend Windows 7. So, will they extend Windows 10? What do you think? You think they will? Yeah. So, you know, I think that there's different answers. You know, Windows 10 is the last Microsoft operating system to not require a TPM chip, and specifically TPM 2.0. Because let's face it, pretty much everything within the past, I don't know, I'll say at least the past 10 years, you're going to have a TPM chip of some sort. Most likely TPM 1.2, but not TPM 2.0. So, would Microsoft drop device support for stuff that's relatively current? I don't know. If it were Apple, I'd say definitely they would. All right. Look at how a lot of the old Power PCs were treated by Apple. All right, when the G5 was released, they were sold up to 2005. What's the last version of Mac OS that Power PC can officially run? It's 10.5.8, right, which was released in 2009. Okay. Now, technically speaking, there is a version of Snow Leopard 10.6.0 that can run Power PC. It's not I mean, it is made by Apple, but it's not officially released. But it's out there. You got an old G5 kicking around? Why not give it a shot? All right. So imagine you bought a computer and 4 years from now it's not receiving updates. Would that kind of suck? Why would that suck? Okay, well, the good news is, you know, 10.5.8 did receive patches for a little while after, I think the last patch was either 2011 or 2012, but still, it's not a very long lifespan. Okay, compare that to a machine from 2005. It's capable of running Windows. More than likely it's capable of running Windows 7, right? That's substantially more support that you receive. You know, maybe it can run Windows 8 and 10, maybe it cannot. I would say more than likely something 2005 cannot, something 2006 probably can. Just given a lot of the differences in the Pentium line versus the Core 2 Duo line. But anyway, getting off topic a little bit, aren't I? So bringing it back to talking about change management, you know, organizations have this completely differently. But if you're at a, you know, I'd say mid to large organization, it's probably going to be laid out like this, okay? You have various IT department heads and maybe a few business heads as well. And they all get together and they meet maybe once a week or so about possible changes. Now, that's not to say there won't be emergency changes. So let's face it. The zero-day exploit is found. Are you going to wait 1 week to have a meeting about it? Probably not, right? Probably going to push the update as soon as you can. What if you're a smaller company, though? How does it work for a smaller company? You just do it, right? There is no formal process for change management. Because if you're a small company, you probably have, let's say 500 or fewer employees. It means the IT department is probably no more than 20 employees, right? Not going to have formalized change management processes likely. So, what is my advice? Well, my advice is to follow your organization's policies and procedures. All right? Now, I say, I don't explicitly say to ignore regulations, but you might believe that I would say that. All right? And that's because not all regulations have consequences. If you ignore your organization's policies, that probably has consequences, right? They're the ones signing your paycheck. All right? And that's an important thing because let's face it. Say you hate your job. Why not leave on your own terms? Why not, you know, keep doing your job, apply elsewhere, do interviews, and then when you land something else, leave on your own terms. Why get fired? Why burn bridges? Let's talk about establishing databases. So those of you in 402, what's proper database design? Want to be relatively normalized, and that means that we don't have a whole lot of redundant information. It means we have it well organized. What else do we want? We want to have logical names of everything, right? You don't just want to have table 1, table 2, table 3. You want to have person table. You want to have, location table. You want to have table names that are relevant to what you're actually storing. Makes everything a lot easier. What else is proper database design? Patrick, give me something that makes a good database. Okay. We'll make sure your relationships are logical. Okay, you want to make sure you have foreign keys as needed. You'll make sure you have primary keys that are meaningful. Ben, give me something else. Exactly right. You know, you wouldn't have first name be stored as an integer, would you? Data validation. Okay, so data validation serves a couple purposes. Okay, number one, as it relates to information security, think about the CIA triad. Confidentiality, integrity, availability. Which one is data validation going to be concerned with? Integrity. All right. So what we're doing is we're saying the data is correct. We validated that it's correct. And it really addresses a couple other things as well, though. All right, so you can make an argument that's going to address confidentiality. And that argument will be based upon the fact that if you're validating your input, it means you're not allowing the input of characters like a semicolon. That could be used to do things like SQL injection. All right, because let's face it, you can type out a couple characters, put a semicolon, and do select star from person. And what's that going to do? That's going to give you everything in the person table, right? So you'd want to disallow that in validation. It's part of validation. What else is validation? It ensures consistency. So let's say that, let's go back to the example I gave in database class. You have United States. You have mailing addresses, right? Who runs the mail? United States Postal Service, exactly right. They have an API that allows you to ensure that the address that's entered matches up with what the USPS has as that address. And that's really useful because you may have 3 or 4 different ways of spelling out an address that may all be the same exact place, right? That's data validation. Okay, and lastly, database security. So we've talked about security a good bit in this class. You might say it's a security class. But when you're securing a database, do you just plop a password on it and call it a day? Do what? Okay, if you're lazy. What do you do to secure it? The permissions are going to be part of this, definitely. Because, let's face it. You got a 10,000 employee firm. Do all 10,000 of those employees need full access to the database? Why not, Ron? It's not relevant to their job, right? So HR, for instance, probably needs to know employees' social security numbers. Payroll probably needs to know employees' social security numbers. Does IT need to know employees' social security numbers? No. That's not to say that there won't be someone in IT who can access them. That's pretty much a given. But the entire IT department does not need to have access to them. So that's part of it. Let's take a step back. More generally speaking, if I were to put a little hangman on the board, I said the first letter is L. What's it going to be? Not least. However, you did get some of the letters. Okay, there we go. What's the answer? Or guess a letter. Colby, guess a letter. Layer. Exactly right. So you want to protect every layer. This is a system, just like any other system we've talked about up to this point. All right. So if you have a database, let's say it's encrypted. Let's say that you have, reasonable privileges, reasonable rights. Everything is done well, except you leave the storage device that is stored on in a closet. that, let's not even say a closet. Let's be more ridiculous. You leave it in the lobby. No cameras, no nothing. What's gonna happen? What could happen? Destruction. All right. That would affect confidentiality, integrity, or availability. Exactly right. What else could happen? Theft. What would that affect? If we have strong encryption, can we assume that it's not going to breach the confidentiality? We can assume that. Not to say that it won't, but we can assume that it won't. So what is it going to affect? Availability. Okay. So understand that any layer that we miss can affect one aspect of the CIA triad. Talk about storage threats. Protect drives. What we mean by protect drives is not only protect them physically, but protect them from an integrity perspective. So to protect a drive physically, is it enough to say I'm going to lock it up? Physical protection, is that enough? Behind a locked door, no one can access it. Let's back up. Could that potentially be enough in some cases? Yes, it could. What does that not address, though? Well, yeah, but I mean, you know, eventually someone's going to have access. So, really what I'm getting at is it protects it from theft, protects it from purposeful destruction. What about accidental destruction? If I just get a really long SATA cable, a really long SATA power cable, and I put a hard drive on the floor, and I jump up and down, what does that do? Is there any protection at all for that drive? Okay, I'm not jumping on the drive, I'm not destroying the drive physically. What do my jumps do? Okay, vibration, which can certainly damage pretty much every part of the drive if it's a spinning drive. Is it fair to say that you may want to have drives be properly mounted? Okay. What does a proper drive mount look like? Well, it depends on the RPM of the drive. All right. You got a 7200 or 5400 RPM, you screw it in, you'll be fine, right? What if it's 15,000 RPM? You got to use shock mounts, right? Now, what's a better approach than magnetic drives in a lot of cases? Solid state. If I jump up and down around a solid state, what happens? I burn a few calories, right? I don't burn a drive. Protect drives is not just physical. Okay? Well, I mean, so when I'm talking about that, it is physical. But let's say that I stick them in a server room that doesn't have air conditioning. It's summer in the South. What does that mean? It's going to get hot. What happens if the drive gets hot? Okay, performance degrades. What else? Can it decrease the mean time to failure? Definitely. It's not going to instantly fail. Stick your drive in 100 degrees Celsius, it won't instantly fail. Well, unlikely. What will happen, though, going to degrade performance and going to make it more likely to fail. Drive permissions. Okay, and also privileges. You want to ensure that people have access to what they need, but not stuff that they don't need. And a lot of times this is going to be done on a per drive basis. I don't mean per logical or physical drive. I mean per basically partition. All right. So the idea is that, you know, you may have a SAN. It may have 10 or 20,000 partitions on it. Okay, so what you're doing is you're making sure that people have access to what they need, but not to what they don't need. And they may need read access to stuff that's shared organization-wide, but they may not need to have write access to that. It looks like I misspelled integrity, but that's important as well. All right? So, 4 letters. First letter is R. How can we preserve data? It's a protocol, sort of. Okay. You said role-based access control. I was thinking something else. It's not a wrong answer, it's just I was thinking of another thing. Give you a hint. If you had a cockroach, you might spray it with this. RAID. Redundant array of inexpensive disks. Okay, so the idea there is that you have disks. Eventually, one of them is going to fail. So you don't just store files on a single disk. You store them on a RAID of disks. Or you have other more modern ways to do that as well. Okay? So, knowledge-based systems. We'll go through these kind of quickly. They don't even really relate to information security that much, to be honest. But they're in the book. Okay, so you have expert systems. An expert system's goal is to provide data that's relevant to a specific, most likely a specific profession. Okay, so for instance, anyone majoring in finance in here? Do we even have a finance major at this school? Okay, I wouldn't know. But anyway, let's say you're majoring in finance. You may have an expert system that may help you make financial decisions on behalf of the company. Let's face it, if you're a finance professional, can you memorize everything that your company's ever spent? Probably not. All right, it's unlikely. It's not impossible, I suppose. You know, but I'm not going to go there. But you get the idea, okay? Machine learning is going to be semi-autonomous modeling of stuff to basically find outcomes. And then, of course, neural networks are going to be where basically it's just how the outcomes are found. Okay, so it's found in a neural net, which is similar to how people believe a brain works. All right? So, just to wrap stuff up, we talked about system development controls, talked about establishing databases and data warehouses, talked about storage, as well as knowledge-based systems. Any questions? All right, I purposely cut today's lecture a little bit short. You got about 20 minutes to work on your project. I'll be up here if you have any questions.